Yes, hi guys. Today I'm talking about determinants. Okay. Now in this playlist of determinants, I'll just talk about that how they are related to the matrix algebra. In matrix algebra, I've talked about some basics of them, and I just in brief I talked about determinants also. But because matrix, sometimes matrix, for example, inverse of a matrix, we have to calculate. In case of application of matrix algebra, there is requirement of determinants. So I talked about briefly regarding determinants there. Now let me take this in detail. What is the determinant? What types of determinants are there? What are the properties of determinants? What is the application of determinants? I'll talk about this in the next lecture series. But before that, what are the different types of determinants? What types of properties are there for determinants, and how to calculate determinants of different orders? Now, determinant of a square matrix only can be calculated. Okay, so determinant is only of square matrices, a matrix of square order, or a square matrix which is having same order, meaning 2 by 2 matrix, 3 by 3 matrix, or single 1 by 1. That means one matrix only. So a square matrix can have the determinant. That is the point. Okay, so I'll talk about what the determinant, how to find out the value of this, what the different processes for a matrix of order 1, matrix of order 2, matrix of order 3 and 4 and on to on. Okay, that I'll talk about. What is Sar's method? With the help of Sar's method, how to find out determinant, value of determinant. What is the application? What is the Laplace extension? Okay, a Swiss mathematician Laplace. And what his method of this is there. Okay, so Laplace, this Sar's, okay, Sar's was a Swiss mathematician. So Sar's method, what is Sar's diagram? Expand, find out the determinant value of determinant. Okay, so that Sar's method is what I've talked about. Then I've taken all these queries from the student side. And what is Krammer's rule? Okay, Krammer's rule. Krammer was a Swiss mathematician. Sorry. Yes, Krammer was a Swiss mathematician. So I've talked about how to use Krammer's rule to solve the simultaneous linear equations. Solve the simultaneous linear equations. What is the Krammer's rule? A shortcut method to find the solution of simultaneous linear equations. That I'll talk about. Okay. Regarding all these things, now on the properties, on the determinant properties, which are 12 or 10 or 12, okay, that I'll talk about in the next lecture series. Property of determinants, so that one can find out what the value of determinant by different methods. There are different possibilities are also there, but different possibilities in which value of determinant can be easily calculated. Okay, so that I'll talk about in the second lecture series of determinants playlist. Okay, in this playlist I'm talking about first determinants definition, then the basic methods, properties. Some briefly properties are described here, but in detail with number of illustration, number of questions based on property of determinants, I'll talk about in the second lecture series. Then I'll take all these methods. What is Sar's method? How to find out values of all these Sar's method and Laplace extension I'll talk about in detail in the next lecture series. But briefly I'll discuss about all these topics. Okay, so today let me take what is determinant. Definition of a determinant. Okay, so determinant definition. Now, what is the definition of a determinant? Let me talk about this. Definition of a determinant. Now, it is a number. Okay, it is a number obtained by solving the value of, or this says that if suppose the unknowns are given, to removing the unknowns, find the value of the determinant. It is a number. It is a number obtained by removing the unknowns, or solving the unknowns, removing the unknown given in the equations, or the value or the number is calculated with the help of minors and determinants. Let me talk about them, and I've talked about them in matrix algebra also. Is calculated with the help of minors and cofactors. Minors and cofactors. Okay, by multiplying the number of the rows and columns. What are the elements of the rows, first row or first column? We can find out that. I'll take that how to find out what is the row and column. Let me just define it in detail. Okay, so if A is a, let me take a matrix or determinant. Now, a matrix is denoted in terms of a square bracket, okay, but in case of determinant is represented in a two vertical lines or between the, if A is a matrix of order, let me take n, okay, then determinant is calculated as follows. Okay, let me take A is a matrix. Okay, I'm taking matrix first, A11, A12 and so on. A1, this is I here, or this is, let me take I and J. This is first is 1 only, because this is 1 we are talking about. 1 J. Okay, and then A1, let me take N here. Okay, M rows and N columns here. This is A21, A22 and so on, A2J, A2N, A31, A32 and A3J to A3. Then 3 dots. Okay, these are 3 dots here. Then this is AM1, AM2. This is, I'm sorry, this 3 2, this is M2 here. This is AMJ. This is MJ, jth column, and AMJ. I could take ith row also, I1, and take here AI1, AI2, this is the last one. And before the in between, you could take I1, I2, IJ here, and IN. Okay, that could also be written as, if we take AI1, this is I1, AI2, AI, this is ith J and ith row and jth column, and so on. This is AIN. Okay, and then 3 dots, and this is AMN. Now this is the matrix. And determinant is represented as A, and this is in vertical lines. This is nothing but A11. We will just calculate this. A12, let me write here. A12, A1J, okay, this is A1J, up to A1N. Then A21, A22, A2J, and A2N. Let me take ith row. AI1, AI2, AIJ, AIN. Then AM1, AM2, AMJ, and this is AMN. Now this is the determinant is represented in vertical lines. This is a matrix. Same matrix is represented in terms of, form of determinant in vertical lines. 2 vertical lines are written down here. And how to calculate the minors and determinants? Let me just define them, and the value of determinants will be calculated. What is the minor here? Let me take minor. Now, minus of every element of each row or every row, let me take every row or column, every row or column. Every element has its minor. Okay, so let me talk about minors. Suppose first element is this, then minor of A11 is represented, then minor of A11 is equal to, this is minor here in form of determinant. We write here A11 leaving this row and this column in which this A11 is lying. So we have to not to consider, we have to not consider the row in which that element is lying and that column in which that element is lying. So this element is lying in first row, first column. So these two are removed, and whatever is left over, that is known as, this is A, this AI2, sorry, A2, A22, this is A22, A22, and so on. This is A2J, A2N, this is minor. Then AI1 I have taken, and AIJ I have taken, and this is AIN. Then AM1, AM2, sorry, not M1, I'm sorry, what I'm doing here. This is only up to 2, 2. This is 2, 2 here, and 2, 2 I've taken, this is I2 here, I'm sorry. This is I2 here, and this is M2. From M2 means this leaving the first row, M2, and this is MJ, and this is AM and last one. So second column and the ith, jth column and nth column, all these are the rows, second row, third row, fourth and the last row. And in this way we have to take all the elements which are lying in other columns and rows which are other than this row, the first row in which this element A11 lying. Similarly, we have to find out other elements. So whatever is left over, okay, for example A12, if I have to find out, then leaving this row and this column, sorry, this row and this column of A12, whatever is left over, that we will take in the manner of A12. Similarly, manner of A12 can be written down. So leaving that row and that column in which that row and this column, second column and first row in this case, A12 if I have to find out. So in this way we have to find out the other. Let me take now this I have taken the general value. Let me take a third row, okay, I mean matrix of order 3, okay, matrix or square matrix of order 3. Let me take that A is a square matrix of order 3, of order 3. Then A is equal to, this is the matrix here, A11, A12, A13, A21, A22, A23, A31, A32 and A32. This is of order 3 by 3. That means order 3 we can say, or 3 by 3 we can write, but it is only of order. The square matrix is denoted by order 3. That means 3 by 3. That means 3 rows and 3 columns. 3 rows and 3 columns. 3 columns and 3 rows. This is the matrix of order 3. Now let me define the minor of each element. Now in this case A11 is having this, A12 is having leaving this is A21, A23, A31, A33. In this way every element's minor can be written. Okay, so the minor is this. In case of minor, no sign is important. Okay, so no sign is important. So minor of A11 as we written down here, this is the determinant form, and minor of A21 from this third one let me take on order 3 matrix let me take. So that will be simpler one. One can understand easily then that how minors are calculated. So minor of let me take minor of every element. So this is I'm talking about minors and cofactors. So with the help of minors and cofactors, the determinant value of determinant can be easily described, easily explained. Okay. That explanation of minor and cofactors I'm talking about. So minor of an element, this is I'm talking about minor. Minor of an element is the determinant of the elements or remaining elements of the remaining elements leaving the row and the column in which that element is lying. That element lies. In which that element lies. Okay. If I take in this case of A11, the minor of A11 is this determinant. Which one? We have to leave this first row and first column. I have already described this in case of matrix algebra. Okay, A22, A23, A32, and A33. This is minor of A11. Similarly, minor of A12 is equal to determinant. Value will be calculated. Determinant, how do we calculate the value of determinant, that I'll describe. But A12 element, so leaving this column and this row, first row and second column, we have to leave whatever is left over, that is A21 to A23 elements, A21, A23, and A31, A33. So these elements are left over. This is minor of A12. Okay. Similarly, other minors are calculated. For example, A13, the minor of A13, leaving this column and this row, A1, A21, A22, A31, A32. This is the leftover minor or minor for this one. So minor of A13, leftover elements. Okay, in that matrix, whatever leftover elements are there, other than the row and that column in which that element is lying. In this case, 13 is lying in this column and the first row. Okay, third column and first row, leaving them whatever elements left over, that is for. And minor of, let me write here, A13 is equal to, I'm writing here, this is A21, A22, A31, A32. This minor of A13. Similarly, other elements, for example, A21. For A21, if I have to find out the minor for A21, minor of all the 9 elements can be calculated. In this case, minor of A21 is what? Leaving this row and this column. This is A12, A13, A32, A33. Okay, so in this way, the minor of other elements can be calculated. Let me take all these minors here, so that the minors and cofactors can be understood easily. Minors and cofactors then can be easily understood. Let me take minus of, now A13 I have written down, A21. Let me write here minor of A21, minor of A22, minor of this is A22, A23, and minor of A31, further minor of this is A31 and A32. A33 is also left over. Right here, minor of A33 is equal to, I'll write down here. Let me take off A33. Now A33 lying in the third row, third column. Leaving this is left over A11 elements, A12, A21 and A22. This is minor of A33, the element A33. Similarly, minor of A21. A21 is second row left over, first row, first column left over. It is A12, A12, okay, A13, A32, A33. This is minor of A21, A21. Leaving this and this row, this column, and the second row, A12, A13, A32, A33. This is minor of A21. Minor of A22, let me write here, minor of A22. So leaving this second column, second row, what is A11, A13, A31, A33, A33. So A22, second column, second row, leaving them A1, A11, A13, this is A31, A33. Okay, so this is the minor of A22. Minor of A23, let me write here. Minor of A23 is this. Leaving the third row, second column. So this is A11, A11, A12, A31, A32. This is of A23. Alright. Then A31, leaving the first column and third row. So leaving this is left over. This is of third A31. A31 I am writing here. This is A1, A12, A31, A12, A13, then A22, A23. This is minor of A31. Let me write minor of A32 here. So minor of A32 is equal to here. A32 means third row and second column leaving. This is A11, A13, A21, A23, A21, A23 of A32. A32, this second column leaving third row in which A32 is lying. Okay, so left over elements are A11, A21, A13, A23, A12, sorry, A11, this is A11, A13, and not A21, yeah, A21 and A2, yeah, A21 and A2. This is what we have left over. This is how A32 and A33 we have already got. These are minors of the elements. Now, what are cofactors? Now, in case of cofactors, then I'll talk about what determinant, value of determinant, then we will calculate. The value of determinant is calculated in terms of minors and cofactors. Now let me talk about cofactors. I have already defined this in matrix algebra, so please see there also I have defined them. But cofactors now is what? Cofactors of elements. Cofactors of elements of a matrix. Okay, Again, let me take A is the matrix here. What is the cofactor of A11? So cofactor of A11 of every element, we can find out cofactor as the minus were calculated. Similarly, we calculate this, but the sign is very important here. Or the sign is calculated. So cofactor of A11 is the determinant, which is represented by minus 1 raised power I plus j. What is I plus j? First row, first column in this case. So this is 1 plus 1. Here it is 1 plus 1. This is 1 plus 1. Whatever minus 1 raised power, if it is odd number, then it is negative. If it is even number, then it is positive. In this case, minor will be in this case, let me take the minor of A1. In this case, A11 is equal to minus 1 raised power I plus j into minor of A11 as we calculate the minors. So minus as we calculated, similarly we calculate the cofactors into minor means minus 1 raised power I plus j. I plus j here is 1 plus 1 of A11 is positive here, it is plus sign minor of A11, which is what? The determinant value. But this is positive value here. It is leaving the first row and first column. Whatever left over is A22, A23, okay, A32 and A33. Leaving first row, first column for A11. Okay, this is the value of minor, determinant value. What is determinant value? We just multiply them, these two, and minus this multiplication. So this value is equivalent, in this case, A22 into A33, A22 into A33. Multiply them in cross multiplication. But second, this is main diagonal values of principal diagonal or leading diagonal. Leading diagonal elements are multiplied together, minus sign in between, multiply the other values, okay, or non-diagonal values. So this is A23 into A32. This is the value of this determinant in this case, the positive value. Okay, but in case of A12, if I have to find out what is cofactor of A12, now in this case 1 plus 2 is odd number, so minus 1 raised power 1 plus 2 will give us the cofactor of A12 as that we write here, and cofactor of A12 is equal to minus 1 raised power. Now I plus j, I here is 1 plus 2, okay, into minor of A12. What is minor of A12? This is equal to negative sign. Minor of A12, leaving the second column, first row, and is left over with A21, A23, A31, A33. So these elements are left over. This is the value of cofactor of A12. Cofactor of A12 we have now calculated. Cofactor of A12 is this. Similarly, cofactor of other elements. Only the thing is the minus sign or positive or plus sign. If it is odd number, sum of the number of row and number of columns we are added up with minus 1 raised power. Minus 1 raised power I plus j, where I represent number of row, j represent number of column. So in which that element is lying. For example, this is A22. What is the cofactor of A22? The cofactor of A22 will be calculated by leaving this column in which A22 is lying, second row, the second row and second column. You leave whatever leftover elements are there, they are put in the form of determinant, okay, in vertical lines, and then calculated value is calculated. Then in this case, this value will be, in this case, this value of A12 that we calculate is minus sign with A21 into A33 minus sign, A23 into A31, A23 into A31. This is the value. So this will be positive, this is negative, this is A23, A31 minus sign A21, A33. This value is of cofactor of A12. Similarly, cofactor of A1 3 will be calculated. Now, let me take what is the final value. So in this way, cofactors are calculated. Cofactors only plus minus sign is to be considered, which is very important to calculate. Just put minus 1 raised to power I plus j, where I represent number of row and j represent number of column. The element for which cofactor is required, what is the position of that element in that matrix? Okay, so the position of that number, for example, A32 is odd number, A32, this is even number, this is the odd number, U1 plus 2, 3, 2, 2, 4. If even number, minus 1 raised power even number is positive, and minus 1 raised power odd number, total sum is odd number, then it is negative. Negative, positive is to be considered before putting the minus. So now let me find what is the value of or answer of determinant. What is the value of determinant of a matrix? Okay. So determinant of a matrix or value of a determinant, let me calculate. Determinant, therefore, the value of a determinant or the value of a determinant is calculated. So the process for that is calculated. So this is equal to, let me write here, the first row, if this is of order 3 by 3, is calculated for matrix or for a square matrix. Here it is a square matrix, sorry to say, for a square matrix of order, let me take 3, of order 3. Then what is the determinant value? So value of determinant, the value of a determinant is calculated for a square matrix of order 3, order 2, etc. I'll just define what is that. This is given by, this is for order 3. You are calculating. This is A11, or let me write here the cofactor value. A11, the value of that element is also multiplied. The element A11 into cofactor of A11 plus A12 into cofactor of A12, or its cofactor we could say, A12 into cofactor of A1 plus sign A13